Today, we have learned more about etching, especially wet etching and dry etching. First, I would like to introduce about the procedure of wet etching. As you can see, there is a three-step. First step here is reactant transport to surface, and second here, selective and controlled reaction of etchant with the film to be etched. Third is transport of byproduct away from surface. Byproduct is the same meaning of form or produce. Etchlate is affected by temperature, concentration, chemicals, etc. Generally, it is isotropic, but it has poor process control. And this is how we use the materials to do wet etching. And next, I will introduce about dry etching. There is some advantages and disadvantages of it. There is first, it eliminates handling of dangerous acid and solvents, isotropic or anisotropic etch profiles, and directional etching without using the crystal orientation of silicone, high resolution and cleanness, less undercutting, better process control, and also ease of automation. Wet etch also has ease of automation, but compared to the wet etching, dry etching has more easier way of automation. And there is a disadvantage. First is some gases are quite toxic and corrosive, and redeposition of non-volatile compounds need for specialized equipment because there is it uses strong plasma laser and etc. And as I talked before, there is two types of dry etching. One is non-plasma based dry etching using spontaneous reaction of appropriate reactive gas mixture. And another is plasma-based dry etching using plasma to drive physical-chemical etching, and such as there is a such sputtering plasma enhanced etch, reactive ion etch, deep RI. And I would like to deal this later. Next page. First, I would like to deal more deeply with the non-plasma based dry etching. Gaseous forms of chemicals are injected into a process chamber and the wafer is heated. Temperature is critical to etchlate, but not only for the etching process, but also it affects to the deposition. And it is generally isotropic, although etching of the surface will occur. A much higher etchlate can result with plasma enhancement. And what is plasma? As you can see in this picture, plasma is different from the three stages of matter, such as solid, liquid, gas. It is fourth stage of matter. And plasma is full of energy and heat at temperature. And there is an electron, and if we give more energy to the electron, it ionizes and is separated. There is three types of state. One is just electrons, and one is ion. And third is radical. Radical is a combination of electrons and ion. And next, I would like to introduce about sputtering. Inert gas injected at low pressure is used as milling tool, and RF plasma in chamber. Here, energy transfer to gas molecules create plasma of equal numbers of ions and molecules. Positive ions bombard negatively charged target, such as wafer, removing molecules from the surface. And for ionic bombardment, no undercurrent since side walls are not exposed, greatly increased each rate, structural degradation, lower selectivity, because it remove that we don't want to remove. And for reactive ion etching, we also call it as RIE, process in which chemical etching is accompanied by ionic bombardment, conflict between etching rate and anisotropic profile, and conflict between damage of high etching rate and anisotropic profile. And next, we have learned about deep reactive ion etching. We also call it as DRIE. It is highly anisotropic etch process with high aspect ratio, deep penetration, steep-sided holes and trenches. And in this diagram, we use TSV method. TSV is through silicon via. And this structure is very efficient to give powers or signals. There is a two type of DRIE. One is typical RIE system, and the other is ICP RIE system. And for RCP system, plasma is generated with an RF-powered magnetic field. Very high plasma density gives an isotropic structure effectively. And this is the process of DRIE, which we also call as Bosch process. First, we use chemical, and if it etches down, after etch down, we cover with the other materials to with coating to protect the chemicals. And next, we use more chemical to etch down. But if we do this step again and again, it looks like this. But if we use oxidation, it becomes like this. So the surface roughness can recover. And thank you for hearing.